Hi everyone. Welcome back to Kikobot's YouTube channel, and today we'll be learning how to control Kikobot C1 using LeRobot's library. So before we dive into it, I'll explain what Kikobot C1 is. So Kikobot C1 is a robotic arm with 6 degrees of freedom, and it can lift up to 250 grams. So those of you who are new to LeRobot, I'll explain what LeRobot is. So LeRobot is an open source powerful toolkit which is based on PyTorch or TensorFlow. So this can be used for your AI applications such as imitation learning and reinforcement learning. And apart from this, the data set which is collected from LeRobot can be used for synthetic data generation, as well as the data set supports NVIDIA GROOT. So if you're looking into imitation learning experiments with your real life robot, you can try LeRobot datasets. So we'll be going through 4 steps for teleoperating the robot using LeRobot's library. The first step is the installation. So in this step, you'll be installing all the dependencies and all the libraries that are required to control Kikobot C1 using LeRobot. So let's dive into it. So this is the first step for installation. It requires you to install Conda if you're using any kind of OS, and this enables us to create a different Python environment in which you can store all your libraries and all your toolkits for LeRobot. So first is installing the mini conda. You can follow the steps given on our website, and since we already have our local setup done, I won't demonstrate these steps as of now, but you can follow these steps to create an environment for LeRobot. The second step is configuration of motors. So Kikobot C1 are equipped with 7 motors on each of these arms, and to configure these motors, you require a Kikobot's controller, which is this. This is the main driver module, which is essential for delivering all the waveshare motor IDs to the motors. And here you can see a standalone version of the driver. So, in the first step, you have to find the motor bus or the port at which your motors are connected. For this, you have to copy this command and then you have to navigate back to your terminal. So, after copying the command, you have to navigate to the folder where your LeRobot's libraries are or where your package is. And once you navigate to there, ensure that your contact environment is activated. After this, you have to just paste this command in the folder and then remove the USB drivers from this. And once you do that, you'll have the difference or the ports where your both of the Kikobots are connected. Now, after you have the ports, you have to navigate to the file where the configurations are written. So in our case, the this is the path where the config files are, and once you navigate to that file, you have to navigate to the line number 499 for finding the Kikobots configurations. And once you do that, you have to change the port for leader arm and the follower arm from here and here written. So the step 1 is calibration of the follower arm. Our follower arm is equipped with a set of gripper which allows us to grip objects. So for doing this, you have to copy this command over here and navigate back to the terminal where your package is present. And when you run this command, it says that you have to navigate to the zero position. So this is the zero position of our Kikobot. Next comes the rotated target position. So this is the rotated target position. Ensure that every joint moves over here along with the gripper too. Next comes the rest position. So this is the rest position of our Kikobot. ensure that gripper is open in this step. Now you have to navigate to your leader arm. For leader arm, you don't have a gripper, but you have a trigger, which is this, which resembles the motion of the gripper. So for the first position, which is supposed to be the 0 position, navigate your Kikobot C1, which is the leader arm, to the 0 position. Next comes the rotated target position, which is this. Ensure that every joint here moves along with the gripper. For this, you have to slightly open the trigger, which resembles the opening of a gripper. Next comes the rest position. So the rest position is this, and open the trigger fully to resemble the opening of gripper. So this ensures that your robots are calibrated. So when you calibrate the robots, you'll see these two files over here. The first is main follow.json. So this file has the readings of all the joints while calibrating for all the three positions. Similarly, you have one for leader arm as well, which is main underscore leader.json. You can find these files over here, which is in cache directory in the Kikobot folder. Now next comes the teleoperation. So with this step, you can teleoperate your robot by using leader as an trigger or as an event to control the follower. To do this, just have to copy this command from our website and navigate back to your terminal, paste it over here, wait for a bit, and then you can now teleoperate the robots. This is the leader robot. The follower will follow all the movements done by the leader. And for gripper's movement, you have this trigger over here. When you open this trigger, the gripper will also open, and when you close, the gripper will also close. So I'll just demonstrate this basic application where you can pick up a cube. You have to be very precise for controlling this robot, or else you'll face difficulties like I did. When you close the trigger, the gripper will grip the object, and you can just lift it and place it in the rack over here. So this is a basic demonstration for teleoperation with Kikobot and LeRobot. So thank you for this video, and if you have any inquiries, you can contact us and we'll help you with that.